Keynote speaker for today's talk is Dr. Neeraj Sinha. The title of the talk is R&D Technology and Innovation Management. Now I would like to invite the session chair, Professor R.K. Gautam, to start the proceeding of the session.
So very good morning to all. So we have Dr. Neeraj Sinha sir, one of the great personality of our Indian government. So it is my great opportunity to introduce briefly him. So today he will deliver the lecture. So that is a R&D Technology and Innovation Management. So I will like to introduce him in brief. So Dr. Neeraj Sinha sir. So after his schooling in Mumbai, Hyderabad and New Delhi, so Dr. Neeraj Sinha graduate with distinction in year 1987 from the REC Surat, Gujarat in mechanical engineering. After a brief stint of a few months in the private sectors, he joined the Government of India, the Department of Non-Conventional Energy Sources, now the Ministry of New and Renewable Energy Sources, that's known as the MNRE, in year 1989. So after doing extensive field duty in the field office of the NMRE, Jaipur during April 1989 to November 1992, he joined the headquarters of the ministry in New Delhi. Amongst the various activities that he handled in the MNRE headquarters during his more than 9 years stint there, so from new and upcoming technology such as electric vehicles, alternate fuel vehicles, hydrogen energy and geothermal energy, in biomass based power generation including that is a biogases based cogenerations. He joined the office of Principal Scientist Advisor to the Government of India, PSS office, in December 2001. And after working there for more than 17 years, has joined in January 2019 the Niti Aayog. In the office of the Principal Scientific Advisor to the Government of India, he had been involved in a wide cross sections of scientific activities, to name a few: oil spill management, underground coal gasifications, bulk encryptions, explosive detections, integrated gasification, combined cycle for the coal-based power generations, night vision devices, setting up for a national knowledge network, multi-purpose national identity cards, climate changes, clean coal carbon technologies, national photonics initiatives, medical sterilizations, spurious substandard drugs and diagnostic centers. So development of the advanced ultra supercritical technology for the coal-based power generations and the development in advanced machine tools. He has actively contributed to the preparation of the National Action Plan on the climate changes, so which was released by the Prime Minister of India on 30th of June 2008. He has a degree of Doctor of Philosophy in Material Science for the experimental work done by him in the Indian Institute of Science, Bengaluru, on the third nitrides energy-related photovoltaic and LED applications. He has co-authored more than 32 scientific papers on his subject. So in the science and technology vertical of the Niti Aayog, he has actively contributed thus far to the contributed international to the Atal Innovation Missions and is guiding currently his preparations of a mission document on the indigenous development and development of the artificial human hearts. So he is a fellow of the Institute of Engineers and life member of the Administrative Staff College of the Hyderabad, and he is also the one of the a prestigious award to the among the material scientists, that is the Material Research Society of India. He awarded in 2018. So I welcome and call to the sir for his presentations. So in brief, so in 30 minutes you have to conclude. Please, welcome sir.
Thank you so much. So thank you so much. First of all, a very big thank you to my colleague who gave such a detailed introduction to my presentation and to myself. A big thank you to the organizers of the AIM TDR 2023. I've been a NAC member for several years, but I've not had the privilege of participating in any of these conferences because of various pressures on time. So I'm glad to be here. I'm very happy to be here. A big thank you to the organizers, especially you, Dr. Santosh Kumar, the head of the Department of Mechanical Engineering in IIT BHU, for having me here, and a warm welcome to all of you on my personal behalf, on behalf of the NITI Aayog. See, the subject I have chosen is primarily out of the fact that nowadays everyone talks about innovation. 30 years ago, people used to talk about microelectronics engineering, and we missed the proverbial bus. Then we started talking about, 2 decades ago, we started talking about nanoelectronics engineering, and now we are talking about innovation. Now, innovation is as old as humankind itself. A very simplistic example that I give of innovation, and I give it everywhere, is that the way we drink hot tea in India. If the tea is hot, we pour it in a saucer and then drink it. That is innovation. So we don't need to complicate innovation to mean high-tech science and high-tech engineering and cutting-edge technology and all those fancy words. Innovation is a simple thing which we do to do things differently, and of course to get economic value out of whatever we are doing. So just a few slides on, just a few slides on what is innovation. I thought I'll differentiate between creativity, invention and innovation. The first row itself makes it very clear. Creativity is a novel idea that is communicated, it is useful and it is appealing. Invention, of course, we know is creating something new, but innovation is making the invention into a product form. And then creativity is ideas only, invention is idea generated from cash, and innovation is cash generated from idea. So now what is the linkage between innovation and entrepreneurship? Innovation, we know, will lead to entrepreneurship because all these, the other buzzword we have nowadays is startups, we have unicorns. We are privileged to have about 130 unicorns in India. Innovation leads to entrepreneurship. Entrepreneurship will lead in turn to startups. Now startups feed into innovation, and it's a two-way street. Innovation will also feed into startups. Now, thanks to some policies of the Government of India that have started about a decade ago, we are now able, in fact, as all of you know, there is a Startup India program, there is a Government of India department which promotes a startup ecosystem by giving all kinds of incentives to entrepreneurs and innovators who want to set up their own small enterprises. So startups have now caught on as a rage in India, and we are glad that we are doing very well there. Yeah, so what is the innovation cycle? We first of all think of the idea that we want to innovate on. Once we are sure that it is going to work, we protect our innovation by defining the IP that goes behind it, and by also learning to patent. I mean, patenting is something we are very traditionally weak in, although there are various mechanisms in IITs especially, and also in the Government of India to look at and to educate people on patenting. But then that continues to remain a kind of a loose end when we talk about research and researchers in India. Now, defending our rights automatically comes out of protecting our innovation, and after we are sure that we have been able to defend our rights, we move on to promoting our innovation. Now this will involve portfolio evaluation, and of course there will be a due diligence process to ensure that the innovation is on track and it yields results. Negotiating our IP contract is less science and more business. Analyzing the patentability of the innovation is also one step which leads to actually making the idea lead to some economic gain. Monitoring our competitive environment is again very important. We need to keep one step ahead of the competition. We had the good fortune of meeting Mr. Sanjeev Bhikchandani, who, as all of you might know, is the founder of Naukri.com, and who would have thought that, you know, I mean, from a obvious need to allow good people to get good jobs, to match biodatas, to match CVs, which the need was always obvious, but it was he who thought about it in the first place. And then he has 3 unicorns under his belt, Naukri.com, then I'm told he has Zomato, he's a promoter there, then he has Jeevansathi.com, PolicyBazaar.com. All these are things that we know of, but the innovation was to get that idea running into a business proposition and actually getting money out of it, And 3 unicorns means the single man's market capitalization is almost 24,000 crores of Indian rupees. So simple in ideas leading to workable solutions, then leading to economic gains, and finally consolidating your own position to ensure that you become a market leader, a unicorn. So developing new partnerships and ultimately optimizing the company's strategy will complete the innovation cycle. Now, types of innovation, we have science-based innovation, we are all aware of, we are all scientists here. Engineering-based innovation is again looking at engineering solutions to needs of the society. Customer-focused innovation is driven by consumer insights and by defining and meeting unmet needs. And efficiency-driven innovation is something which I will talk about a little later. I have a case study, a couple of case studies here. Dr. N. Ramesh Babu, I think, is left, and I had the privilege of working with him on an innovative idea of making the best-in-class grinding machine, which surpassed Studel-make grinding machine, which is made by Germany, in all its cutting parameters. So it's still working in IT Madras. If someone is here from IT Madras, I'm sure you'll know. So, and efficiency-driven innovation is something which I'll talk about later. It is advanced ultra-supercritical technology that was done along with the Bharatiya Electricals Limited, the Indira Gandhi Center for Atomic Research, and the NTPC Limited. The whole thing was anchored by the Office of the Principal Scientific Advisor to the Government of India, where we were successful in not only designing but also demonstrating overall thermal efficiency of a thermal cycle, increasing from about 41.5% to about 46%. So that is efficiency-driven innovation. Now, these are the various waves of innovation. I thought I'll map it. I mean, it's all out of my own thought process. Could be a little here and there, but the first wave of innovation came from 1785, went on to 1845, and the first wave was primarily iron and, of course, water, power mechanization, textiles and commerce. The second wave was steam power, railroad, steel. That was from the period 1845 to 1900. The third wave was electricity, chemicals, ice engines, which was from 1900 to 1950. 1950 to 1990, we had the fourth wave, petrochemicals, electronics, aviation. And 1990 to 2020, I mean, until recently, we were on the fifth wave, digital networks, biotech, software, IT, and whatnot. Now, the sixth wave, according to my own perception, is a radical resource productivity, whole system design, biomimicry or biomanufacturing or biofoundry, as we may call it. And of course, renewable energy and green nanotechnology. Green energy is again being looked at very, very closely by everyone concerned. So green nanotechnology, I thought, could be the sixth wave, which starts from 2020 and is currently going on. Now, what are the policies that we talk about? The Department of Science and Technology in the Government of India had started just before we were struck by the pandemic in the year 2020, a process to define the science, technology and innovation policy of the Government of India. We call it the STIP, the STIP. It took some time for the policy to be formulated because things were across the world in a bad shape because of the wave 1, wave 2 and whatnot, and wave 3 as well of the pandemic. But finally this policy is in shape. I believe it is yet to be promulgated by the Government of India, but it is under discussion stages at a fairly senior level. So here we all know that our own GDP, our own expenditure on R&D is limited to 0.7% of the GDP. Now, the first and the foremost thing that we thought about is increasing funding for research, increasing funding to the extent of 2% of the GDP over the next 5 years. That's a very ambitious target. It won't happen immediately, but fine. That's a target we have set in the STIP. We call it STIP 2020, although it is yet to be officially announced. Investments would be attracted through public-private partnership mechanism and establishment of a fund for innovation for social inclusion, small idea. Now this has already been done. All of you are aware of the National Research Foundation, which was announced by the Government of India, I think about 4 months ago. We are talking about creation of a fund of 50,000 crores of Indian rupees spread over 5 years, out of which about 10,000 crores has come from the Government of India, and the balance 40,000 crores will be mobilized from PPP investments and also from the private sector and also from other mechanisms like equity participation and others. The NRF the distinguishing feature is we don't talk about science-based research alone, we are talking about social science research as well. So hence we talk about social inclusion there. Now, strengthening the linkage between stakeholders, for ages we have spoken about academia-industry interaction. We keep talking about the need for a closer collaboration because academicians have their own strengths. They are 100 on knowledge, but when it comes to technology delivery, maybe they are not as strong as the industry. So this is something which Dr. R. Chidambaram, the then principal scientific advisor, used to talk about very passionately. He used to show a slide, I don't have it here, where he used to give in a binary system to the academia 1 for knowledge and 0 for delivery. And he used to give 0 to the industry for knowledge and 1 for delivery. So if you marry the two together, you have 1 on both sides. Now, this is again easier said than done. This is another policy that we thought should work. For example, in India, very often we have researchers working on problems that they define on their own or that are put to them by their own institution, by their own peers, but they may not be working on technologies or technological solutions which may be required by the industry. So there is the disconnect. Likewise, the industry is more happy importing, is more happy doing N-1 technology rather than N at a price which might be much higher than developing it ingeniously, but they don't want to go through the cycle of innovation, discovery, science-based technology development and whatnot. So the problem is on both ends. So what we thought was, and this is included in some form in the policy as well, that if we are able to get the industry, and this has happened in some measure in the Indian Institute of Science and the Bharat Electronics Limited, if we are able to get the industry to post their own engineers, their own scientists full-time with an academician of their choice, in an institute of their choice, and they are paid salaries as if they are working in the industry and not in an academician's place. And the academician is then able to give them problems which may or may not be linked directly to the industry concerned. They are working full-time, they are working as scientists, but they may be alternately, subconsciously solving problems of their mother industry. This has happened in the ISC Bangalore. There was a project we did there where there was a metal organic chemical vapor deposition reactor, MOCVD reactor, which was set up by the Bharat Electronics Limited in the Material Research Center of ISC Bangalore. And 3 engineers full-time in BL uniforms were posted with the professor there, and they were working on the development of thin film devices, which they successfully did, by the way. But then it was not able to be commercialized because of various reasons. So this is one thing which should be happening much more actively in India. It happens abroad, we all know that. It doesn't happen in India. And promotion of science, of course, is obviously stated. Now, risk-taking ability. Now, this is also very important. Very often, especially in the government sources, in the government level, we don't look at failures very kindly. And we tend to shy away from projects that might be difficult to implement, that might not necessarily lead to a positive result and a positive technological development. Now this this mindset needs to be changed, and we need to emphasize risk sharing by the government, which is obviously implying a significant increase in share of investments by the private sector companies as well. IP I have spoken about. It is very important for us as researchers to ensure that we are able to protect our IP, and we are able to also ensure that we translate the IP into economic gain. Addressing the innovation value chain is obvious. The policy enables a holistic approach to the complex value chain of innovation by providing S&T intervention at all levels of research. And participation in global R&D infrastructure, the Department of Science and Technology already does it. We are already involved in a lot of global R&D projects like the CERN initiative, the Large Hadron Collider project. I'm sure all of you know about it. And very recently the LIGO project that was sanctioned by the Government of India. So we need to increase our share in global R&D is what is being said here. Now after having given a brief background, let me talk about what the NITI Aayog itself is doing to promote innovation across the country. Now, I'm sure some of you may be aware that there is an Atal Innovation Mission in the NITI Aayog that was started by the current government in the year 2016. This is a unique initiative in the sense that NITI Aayog generally does not implement programs. We are supposed to be the think tank of the Government of India. We are not supposed to spend money on any kind of R&D work, any kind of technology development. But Atal Innovation Mission, I am calling it AIM from now onwards, takes a slight break from the routine. What we do here is, amongst the most popular programs, this slide gives you the list of what programs the Atal Innovation Mission does. Most popular amongst them is the Atal Tinkering Labs, which are implemented in schools. Schools are given about 20 lakh rupees as an upfront funding to develop a lab, populate the lab with instruments and populate the lab with equipments that may be useful to students of that region of India. Allow the children to work there at their own pace, allow them to think and allow them to innovate using whatever is available in the lab. So there are 10,000 Atal Tinkering Labs across India now. I don't have a map, but if you look at that map, you will find that every region of the country is covered, including Jammu and Kashmir. So, that is one important initiative at the grassroots, where you ask children from the class 6 onwards to start tinkering. Now, a larger initiative is called the Atal Incubation Center, and the EIC is Established Incubation Center. And I think BHU has an Atal Incubation Center here, in not the ITBHU, but the BHU. The Atal Incubation Center will allow an academic institute or an industry or even a school to set up an incubation center where they are able to incubate startups. And the larger the number of startups that they set up and the larger the numbers of startups that they exit is a measure of how successful that Atal Incubation Center is. The funding there is generous. The funding given is 10 crores per Atal Incubation Center, and quite a few of them have been very successful. I don't have the list here, but then this has been a very successful experiment of the Niti Aayog. Now, the next category are the Atal Community Innovation Centers, which are also incubation centers of some kind. But here we are not talking about housing them in an industry or in a academic environment. We are talking about community innovation here, and they are more regional in nature. For example, long ago when I was in the office of the Principal Scientific Advisor to the Government of India, we all know that we have gharats in Uttarakhand, and gharats are traditional flour mills which use the head, the potential energy of water, to drive a mill. Now, what we did was, we got the Bharati Electricals Limited, which has a unit in Haridwar, to work a little more on that grinding wheel, and the impellers were kind of perfected a little more, and instead of producing flour, the mill started producing power. It was small hydro power in a way. So this was enough to actually give electricity to far-flung areas where the grid electricity had not reached. So these kind of community innovations are supported under the ACIC. And finally, there is an Atal New India Challenge, where there are challenges that are announced by the Atal Innovation Mission, and those challenges are responded to from across the country, and the challenges are then scrutinized, and there are about, I think about 2 crore rupees is given to each challenge to deliver in a given time frame. So, and this has been a very successful experiment of the Niti Aayog. If you can see the number, there are 10,000 ATMs. There are 72 Atal Incubation Centers that have been set up. 30% of them are led by women. There are 14 Atal Community Innovation Centers that have come up. And there are 56 challenges. We call them ANIC, Atal New India Challenge. And they have been supported by 55 startups. And there are 145 new startups that have been selected to implement those challenges. There is a Mentor India program where people voluntarily support innovation. They have been enrolled by the Atal Innovation Mission to help innovators in a structured manner, and this is a voluntary exercise that innovators do. The Vernacular Innovation program is currently underway, where we are, it is not Hindi and English alone. India is rich of languages, so there are about 22 official languages that are being supported for doing research across the country. So that is currently going on. Now, having said this, I thought let me talk about innovation at the global level. Again, we all know there is a Global Innovation Index, and incidentally the Niti Aayog has been mandated by the Government of India to ensure that India continues to rise on the Global Innovation Index at a fast pace. And in the NITI Aayog, it is the science and technology vertical where I work, which is actually mandated to do this job. There are about 29 global indices, which the government of India is very keenly monitoring, and GII is one of them. Now here, as you can see, from 2015, we were at rank 81, and now we are at rank 40 in 2023. Now, people might wonder we have not gone up. 2022 and 2023, we remain at 40. Now, this was the period when we took the World Intellectual Property Organization that publishes the GII annually, took the data from the pandemic year. And thanks to the fact that the world was topsy-turvy at that time, America has gone down by 1 slot in 23 as compared to 22. China has gone down by 1 slot. South Korea has gone down by 4 slots. Netherlands has gone down by 1 slot. The fact that we remain at 40 is creditworthy, given the size of the country and given the size of the damage done by the pandemic. So, just a little about the Global Innovation Index. There are 80 indicators here, and all these 80 indicators may not be tuned to the way we innovate in India. For example, there is an indicator that talks about entertainment, and in entertainment there is some indicator that talks about feature films. Now, the World Intellectual Property Organization takes only Hindi movies into account, Hindi feature films. So, what NITI Aayog is currently doing is, it talks to the World Intellectual Property Organization on the one hand, and it talks to the innovators through the state government, through the central government ministries and departments on the other hand. And we impressed upon the World Intellectual Property Organization that India is not Hindi alone. There is a very vibrant regional film industry which is doing equally good. So, you should be taking into account the regional films also that are released in a given year. Fortunately, they listened to us, and our rank in that indicator went up drastically. That is one example. There are others also. And on the other hand, our own stakeholders in the Government of India tend to be a little reticent in providing data to international organizations from where the WIPO picks up the data. What I mean to say is, suppose NITI Aayog provides data, updated data to the WIPO directly, the WIPO does not consider that. They say we are not going to accept data from any country or any country's government. We have our own sources to pick up the data, and the sources are largely UN-based sources. It could be UNIDO, it could be the International Monetary Fund, it could be the World Bank, it could be the UNEP, and etc., etc. So, Government of India, despite good work happening in India, was not giving data in an updated manner to these sources. That is, these sources from where the WIPO picks up. So, through our own efforts for the past 3 years, NITI Aayog has been banging hard on all these stakeholders to be a little more proactive, be a little more fast in providing data. So, that has also yielded some result. And now, instead of data as old as 6 years, which we used to do earlier, now we give data which is just 2 years old. So, that itself is a big achievement given the size of the country. So, this is what we are doing here. Now, the Global Innovation Index, just a few highlights. Relative to the gross domestic product of the world, the different countries in the world, India's performance is above expectations. Now, this is very good because given the size of the country, again, we are that large green circle that you see on the graph, and this has been kind of appreciated by the WIPO as well. Now, this talks about a consistent performance. We have been going up the ladder 13 years in a row, and India ranks in the top 10 for 7 indicators. There are 80 indicators. Out of those 80, in 7 indicators we are top 10, and we are best in the region as far as Central and South Asia is concerned. And finally, India is best in its income group, and at times performs even above higher income groups in some indicators. And until last year, this time we have slipped. Until last year, we were number 1 in the world in ITES exports, IT-enabled services exports. We were number 1 in the world. This time we have slipped to, I think, number 3. But still, it is good. Now, a little more on the index. Thanks to the GII being there for so many years, the NITI Aayog started bringing out the India Innovation Index. Now, what it means is we are doing a regional evaluation of the states in the country. the mandate is to promote both cooperative and competitive federalism. So we are also trying to emulate the GII. We have about 70 indicators in the Indian Innovation Index. It is brought out annually by the Niti Aayog. We started only in the year 2019. So the Indian Innovation Index of 2022 is about to come out. It has been delayed a little, but very shortly we'll publish it. As expected in that, the leading state is Karnataka, followed I think by Telangana and then by Maharashtra. UP comes at number 6. And there are 3 categories there. One category is major states, in which Karnataka is always consistently number 1. Then the second category is hill states, and the third category is city states. So city states we have Chandigarh number 1, Delhi number 2, and in hill states I think if I remember correctly it is Uttarakhand which is number 1. So this is also being brought out, and this is something which is valued by the states, because what these indicators do is they tell you where you are weak and where you need to improve. In fact, if you look at these, the Indian Innovation Index is available on the website of the Niti Aayog. If a state government is really very keen to improve its innovation capabilities, if they look at the report closely, they will realize that there are some indicators they might be doing well, there are some others they are doing very, very badly. So hence, they tend to take this as a basis for either formulating new policies or redirecting policies that are already existing. So now this is all about Indian Innovation Index, and there is one point I wanted to highlight here. India has traditionally been very weak in R&D expenditure by the industry. I mean, if you look at the US, in the US hardly 35 to 40% of expenditure on R&D comes from the state. Here it shows much lesser in fact, but broadly we say 35% of the R&D expenditure comes from the state, that is from the government, almost 70% comes from the industry. India it is reverse, and we need to improve this because industry is reticent in funding R&D for whatever reasons. Maybe they want quicker gains, maybe they are not confident of India's own expertise, which is not correct, and the only way to do it is the industry should proactively post their engineers with, let us say, a professor in IIT BHU in a department of their choice where they would like some work to happen, which will actually feed back into their own operations. All this I am going to skip now. Technology readiness level, commercialization, market. I mean, this I can probably share with. There was a techno-commercial readiness and market maturity framework on which we in the science and technology vertical prepared a paper. This paper was largely circulated. In fact, it was so largely circulated that we got 3 parliament questions in the current session from MP across India. So we are glad this is a little involved. I will not discuss this here. Finally, I wanted to go to the case studies because I think I'm having only 5 minutes left. So yeah, this is what I was talking about. Now here broadly, we have been setting up thermal power plants. We all know that. We have been manufacturing turbines largely in the Haridwar unit of the Bharat Heavy Electrical Unit. We all know that as well. We have been manufacturing boilers in the Tiruchirappalli unit of the Bharat Heavy Electricals Limited. That also is known. The one thing we didn't know, and most of us might not know, is it's all based on imported design and all based on imported technology. The IP is held by either Siemens or GE. It was earlier Alstom, but Alstom is now absorbed by GE, so just 2 companies. The turbine that we make in Haridwar are all based on imported technology. The design comes from there. We cannot change a single of dimension. If we want to do that, we need to go back to them. So this was, and in a country like India, where we have so much of expertise, it was something we wanted to correct. So what we did was we got the Bharat Heavy Electricals Limited to partner with the NTPC Limited, which is the biggest power producer in the country. And we got them to partner with the Indira Gandhi Center for Atomic Research, which is a lab of the Department of Atomic Energy in Kalpakkam. Now this is innovation which is demonstrated. That's why I took this as an example. And we gave them a challenge, and this was way back in 2010. We gave them a challenge that you 3 get together, instead of subcritical parameters of steam, which even that we don't manufacture in India. We challenge them to go to advanced ultra-supercritical parameters of steam, which is 710 degrees Celsius temperature and about 300 bar of pressure. And from simple thermodynamics, we are all mechanical engineers, we know 1 minus T2 by T1. lesser the T2, higher the T1, bigger is the efficiency. So, where T2 is the exit temperature from the turbine and T1 is the entry temperature into the turbine. Now, so we challenge them to come to an overall thermal efficiency of 46%, whereas the supercritical thermal power plant which are currently being installed across India, again on imported technology, target about 41.5% overall thermal efficiency. It was a tall order, but over a period of 10 years, and these photographs show, I'll show some photographs further. I don't have the time to go into it, but over a period of 10 years, we have been not only able to design an 800 megawatt electrical thermal power plant based on AUC technology, we are also now pushing the government of India to share some amount of risk and then set up the first advanced ultra-supercritical thermal power plant of the world in a place called Gadarwara, which is, I think, somewhere in the central part of India, probably in MP, which is supposed to be a green project site of the NTPC Limited. Now, we are ready with the design. There is a project document that is ready, and it is supposed to get the approval from the cabinet. And by the way, to do the R&D, these three, I mean, there was obviously money required. So there the government of India was generous. In August 2016, the cabinet had approved a project to spend money on R&D for developing this technology in India indigenously, wholly indigenously. There is no following collaboration. Now, I have spoken about all this. Now, this captures subcritical, supercritical and advanced supercritical parameters of steam. So, I have spoken about that as well. 46% is what we have achieved from 41.3%, which is based totally on imported technology. Now, I have given the background. This is the collaboration between the IGCAR, the BHL and the NTPC. Now, one challenge, one big technological challenge was the turbine, as we all know, has a low pressure part, a intermediate pressure part and a high pressure part. So the high pressure part was supposed to be in a high temperature alloy that has been developed by IGCAR, Mishra Dhatu Nigam Limited and NFC in India. And that high pressure part was to be obviously welded to the low pressure part of the IP and the LP turbine. And there we needed dissimilar metal joining. Now dissimilar metal joining has never been done in India. So this was developed totally indigenously by IGCAR and perfected by the BHL. You see the welding of the IP rotor to the high pressure rotor happening in the BHL unit in the Hyderabad unit of the BHL. Now again, the validation of whatever theoretical calculations that were done was done in the Dadi unit of the NTPC by making loops. Now these are all loops of alloy 617M and Sanicro 25. These are two different high temperature alloys that are used, and these loops were inserted into the boilers of the Dadi unit. The temperature was simulated, the pressure could not be simulated, of course. So the temperature was simulated and these were tested to be absolutely working fine, and whatever corrosion was happening was within the design limits. So this was also one of the important achievements, and of course I have already summarized this. Now Dr. N. Ramesh Babu has just left. I was mentioning this in the beginning. I'll just take 2 more minutes. When I was in the office of the Principal Scientific Advisor to the Government of India, again, I'm sure some of you might be from the machine tool industry, I'm not sure. The IMTMA is supposed to be a sponsor of this event. So, the Indian machine tool industry was languishing about 10 years ago, just because of China flooding the Indian market with cheap and maybe, I wouldn't say substandard, but whatever, but cheap varieties of machines that could not be matched by the Indian manufacturers in any case. The prices could not be matched. So they were crying for some help. We then started a mechanism called the Core Advisory Group for R&D in the machine tool sector. This was done by the Office of the Principal Scientific Advisor to the Government of India. A very good example of academia-industry interaction. We did several projects. I'm just highlighting one. I was hoping Dr. Ramesh Babu would stay back, but he's left. So he was the principal investigator of this project from IIT Madras. And we got the leading grinding machine manufacturer in India, the MGTL, Micromatic Grinding Technologies Limited, which is based in Ghaziabad and Bangalore both, to partner with the IIT Madras. And then funding was done by the PS's office, but 25% of the project cost came from the industry. And after a period of about 3 years, and by the way, the machine that we wanted to surpass was a Studer make German machine, which is supposed to be best in class in those days. I don't know whether it's still best in class. And we were able to demonstrate that India can deliver this wholly indigenously. And this is still present in the IIT Madras. And a large contribution came from the advanced machine tool testing facility. And our colleague from AMTTF is sitting there. The entire machine was tested indigenously, test protocols were developed, testing parameters were developed, test facilities were created in Bangalore. And now this machine is being used by industry, I hope even now. Maybe he can tell better. And TVS and all those industries in that region come and do their jobs on this, and of course pay some money to the IIT Madras for this. And this machine surpassed the student make machine, the best in class at that time, in all the cutting parameters. I mean, there's some photographs, Dr. R. Chidambaram and Dr. Ramesh Babu, you can see there. And this was inaugurated by Dr. R. Chidambaram in the year 2016, if I remember correctly. It's still working there. So this is what I spoke about, the core advisory group for R&D in the machine tool sector. And by the way, this led to the Ministry of Heavy Industries. My final point, the Ministry of Heavy Industries was called the Department of Heavy Industries at that time. Whatever innovation was seeded through this project in the Government of India grew in scale because the DHI was so convinced, and by the way, it's not a scientific ministry, it's a bureaucratic ministry. It was convinced that the same group of people can end up doing a lot more things other than the next generation precision grinding machine. So this led to the sanctioning of, if I remember correctly, 11 projects by the Ministry of Heavy Industries, and they spent about 100 crores of rupees or maybe more. All these projects were funded to various industries. Major funding came from the industry, minor from the Government of India, and they were all rooted in the IIT Madras, and out of, except one, all other 10, the balance 10 projects have leaded to products. And this was scaling up of whatever innovation which was started through the IIT Madras project, the NGBG project as we call it. You can see that the DHI versus the industrial partner was 80 to 20. Thank you. I hope I maintained time. Thank you so much.
Thank you very much, sir, for being on time.
Thank you.
So, it will be welcome. Yeah, one or two questions.
Good morning, sir.
Namaskar.
Thank you very much for your talk. I am
at all.
Professor Jose Matthew from NIT Calicut. Sir, you are mentioning about the industry collaborations.
Yeah.
That a professor of practice, in fact, NIT Calicut, we started that professor of practice, visiting professor, adjunct professor, and co-teaching.
Okay.
And at present, we have 4 professor of practice with us, and 6 professor of practice and 4 adjunct professors from IISc Sana. This professor of practice working people getting is very difficult. So how can you help that? Because those who are retired are there, but if we can get the working industry experts as a professor of practice to the institutes, I think IITs, they are getting other institutes, if some mandatory things coming from government, it will help us.
No, see, according to my limited knowledge, the professor of practice is an outcome of the National Education Policy of 2020.
Correct, sir.
And in the NEP 2020, I think we have not restricted industry from coming in. I mean, it's up to you.
And it is there, but we are not getting. That's what I'm saying. It is there.
Okay, you're not getting. So that again is a demand supply situation. I mean, if you think that there is a demand for industry professionals to come as professor of practice in your institute, the vice versa may not be happening. I mean, you want them to come, but they don't want to come to you. So probably the IITs take a major share of everything, and they are taking a major share of professor of practice also. But we can correct that situation. Maybe we need to, you're right, maybe we need to impress upon the Ministry of Education to give some better incentives to people who would like to join not just IITs but even NITs and universities as professor of practice.
And so the CRS fund, whatever
that's a good point. I can take it back to Niti Aayog.
Because otherwise it is fine, sir. We are getting very good response because we floated 6 months back and the response is very good. And all this category we are
No, but there should be some other, you're right, there should be some better incentive given if someone wants to join NIT Calicut, for example, instead of IIT Palakkad.
Thank you, sir.
Thank you.
Thank you, sir.
Just may I add a point?
Yeah, please.
I come from the industry, sir. So one of the things is, at least from the industry, and I'm somebody with about 20 plus years of experience, we notice that IITs and NITs don't want people with 20 years of experience. They're asking for 40 years of experience and only retired people. Incidentally, we're finding that it's
No, I didn't know that. 40 years of experience is, you'll obviously get retired people.
that is one of the things, because I also
No, but I don't think it is mandated in a NEP, to the best of my knowledge.
Yes,
Yeah.
sir, but I sit in the board of governance of a couple of triple ITs.
Okay.
And I've been pushing them, saying that you need to get people in their 40s and early 50s.
See, that is when you do research.
Yes.
That is when you.
However, that's not been happening.
I mean,
But
the
I had a question
Yeah.
from the Niti Aayog.
Yeah,
The very interesting slide you put on entrepreneurship and startup.
right.
And I also know that IIT Madras has one of the mandates as to how to enable most of the IIT graduates to get into entrepreneurship and to stay back in
Yeah, they have a
India.
research park there, no? They
Could
have
you
a-
add some thoughts to it, if that's all right?
See, I'll tell you, IIT Madras is a good example because about a decade or almost 15 years ago, there was a research park that was developed in the IIT Madras. And I'm sure all of you might be aware of it. What they did was they built a separate building which is next to the IIT campus. I mean, it's a part of the campus, but it has a separate boundary wall. And they allowed entrepreneurs to come, give them space, give them facilities at a subsidized cost, and then give them the advantage of taking help from the faculty which were next door, and then set up their enterprises and grow from there. And once they grow, it was like an incubation center. Once you grow, you can always move out. So that has been a very successful experiment. I mean, that needs to be replicated in other institutions as well. This is what I was talking about, academia industry interaction. Dr. Chidamam's slide, I don't have it unfortunately here, that 10 and 01 is the best way it I don't say it is absolutely zero. I mean, knowledge in industry is not absolutely zero, that is wrong. And similarly, technology delivery in academia is not absolutely zero, it is something in between. But if you look at the expertise of the academia, it is knowledge. If you look at the expertise of the industry, it is delivery. Why delivery? Because they need to earn money, they need to be in the business. I mean, if you don't earn money, you close down. So bringing them together gives you a 1-1 situation. And that is a winning situation. So, but you know, it is easier said than done. Somehow, both ways, it is not as good as it should be. I mean, the industry should be willing to post their engineers full-time with a given professor. We keep telling this, we have been telling this for 15 years. And the academicians should also be willing to work on problems, not of their own thinking. They should do that. Basic R&D is very important. But you should look what is called directed basic research as well. Look at problems of the industry. If the industry is willing to take their help, probably work on them. That is how we can promote. There is no other way. I mean, the US does it all the time. All of you know this. So,
yeah, this is Ramesha from Malta, sir.
Yeah.
I got to know many initiatives from Niti Aayog,
Yeah.
the research and development and KACs and stuff. We look forward to contribute to the cause. Let us know what is the forum through which we can connect and identify the projects on which you are working and help the research and innovation through our software solutions.
yeah, see, I'll tell you, Niti Aayog, as I was telling you earlier, other than the Atal Innovation Mission and other than another program which is not scientific, it is called Aspirational Districts Program. And now there is another one launched by the PM which is called Aspirational Blocks Program. Other than these three, Atal Innovation Mission, ABP and ADP, we don't implement anything. I mean, we don't have money to fund research, unlike my earlier office, but
Non-financial.
but we direct a lot of research. And for example, in one of the departments here, I will not name the department, in IIT BHU, there was some very good work being done by one of the faculty members. So that faculty member applied it to the Department of Science and Technology for funding. The funding required was a little major funding. Obviously, the DST was taking no swing time. So what we did was, I mean, when it came to our notice, we got the DST to understand the importance of funding such good work on time, and ultimately that project was sanctioned recently. So we do a lot of advisory work, and generally ministries and departments, especially the scientific ministries and departments, will pay heed to what we say. And there are 12 scientific ministries and departments in the Government of India, so I mean, that should not be a problem. If you have any good idea, if you want that good idea to be taken forward, and if you want to...
We want to catalyze the activity.
That's right. So you are welcome to, it depends. I mean, if it's only science and technology, then you have to talk to us. There is a science and technology vertical in the
I'll write an email to you, sir.
Sure. And if there is any other subject, it could be education, it could be the NEP. We are sitting in a premier education institute right now. There are different verticals. There are about 18 verticals in the Niti Aayog, looking at different topics. There is one on infrastructure, one on electric vehicles, one on rural development, one on sustainable development goals, one on SNT. So, almost everything under the sun is handled in the NITI Aayog. So, we are there to help you to the extent possible.
Thank you, sir.
Thank you. So, if there is nothing else, then thank you for listening to me. And thank you again for giving me and the NITI Aayog this opportunity. Thank you so much.
Thank you so much, sir, for such a wonderful talk. Now I would like to invite our session chair to facilitate our keynote speaker.